Hello, my name is Zane, and I'm Candrone's GIS and Data Solutions Specialist. Today, we're going to go over how drones are assisting or complementing traditional manual surveys of timber inventory. If you've ever cruised timber, you know the routine. You get your flagging tape, you set up your blocks, you pull out your clinometer, and begin your mission. With this kind of work, you're often measuring a fraction of the forest, maybe 2 to 5% depending on the location. From here, we extrapolate from this area and assume our plot is at least somewhat indicative of the total forest. This method has been the backbone of forest inventory, but admittedly, it's kind of slow. It can be difficult over complex terrain, and you have to deal with the assumption that what you measured is an average sample of the total forest. In this video, I want to show you how aerial LiDAR can assist in assessing timber inventory. We're going to take a look at a point cloud from an aerial survey over a forest and pull a full tree inventory out of it. Tree counts, tree heights, crown diameter, canopy area, and ultimately a digital twin that lets you be in the forest at any time of the day. So above everything else, the major advantage of any aerial scan, be it LiDAR or photogrammetry, is that you can actually capture the entire forest and leave behind the assumptions of extrapolating from a small subplot. While manual timber inventory will always be extremely accurate, assuming the individual is proficient with the process, modern advances in LiDAR have allowed for such great foliage penetration that we can extract dense ground points from within the point cloud that allow for near full forest reconstruction in software like LiDAR 360. Here, you can see a LiDAR dataset collected over a small forested region. When viewing the forest by height, it's clear that there is one major issue. The height is calculated from a set ground level, not from the base of each tree. When doing manual timber inventory, you measure each tree individually, which solves this issue. With a LiDAR point cloud, we will do some processing to automatically generate the same result. After we calculate the ground class, which is an algorithm that decides whether a point is true ground or not, we'll then use this ground class to normalize the entire point cloud. This normalization step is doing for us what a clinometer does for each tree one at a time in the field, except it's doing it for the whole dataset at once. Now when we view the point cloud by height, we see that the elevation of each tree is relative to its base, like a manual survey. We can go over to a single tree and use various measurement tools like this height tool and do a manual survey on each tree if we would like, all from the comfort of a computer, regardless of the time of day or weather outside. We can go one step further and do a profile cut, which gives us the superhuman ability to cut the earth into slices for easier measurements. However, this is just the beginning. We want to make use of this software to automatically extract the tree statistics so we can spend more time analyzing the data and producing necessary reports. First, we'll segment our point cloud. This will not only colorize each tree so it's easier to delineate each one, but also produce a table that can be used for further filtering and calculations of the forest that we scan. Once completed, you'll be able to load in this data and get on to what is really important, the analysis. By pairing a handful of well-placed field plots with a drone LiDAR survey, you turn a 2 to 5% sample into a near-complete inventory, with a spatial map of the forest that can be accessed at any time from anywhere. Keep an eye out for another one of our videos where we will take a deeper dive at the forest statistics in the context of researchers. Thank you so much for watching.